Thank you. I will talk about, well, streaming. My name is Abel Braaksma. I'm from Exselt.net. We have been developing over the last couple of years a new XSLT streaming processor. I'm also a member of the working group, and as such, I've learned a thing or two about streaming, which I want to talk about here. The talk will be about a small introduction about streaming for those of you who are not too familiar with it. Then I'm going to try to wrap the gazillion of rules that we have about when something is or is not streamable and put that into a small subset of 10 rules that fit 95% of your scenarios, I hope. If there's time at the end, I like to go over a slightly more complex scenario through the flowchart to see how it works when those 10 rules don't pan out, and well, then I'll end with a small conclusion. Streaming, for many people, feels like too much. It is overwhelming, it's complex, it's hard, it's with big data, it's with something called streams. It's about you can go down, you cannot go up, and you have to think it through. Many people seem to try to stay away from that. If they don't have to use streaming, then it won't get too complex. And just to find out, and maybe I will ask this question again next year, how many people of you have used streaming with XSLT or another technology in practice? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Like, okay, you haven't used streaming. 10, 11, 12, 13, 14, 15, 16, 17. So give or take, there are like 150, 170 people around here. About 10% of you have used streaming in practice. Let's try to make streaming a little bit more easy, a little bit a lower entrance for people so that maybe it can open up to a larger crowd. When you think about streaming, the first question you have to answer is, well, should I apply it to my scenario? An obvious one is input data tree size. If your XML data is, well, huge, it doesn't fit in memory, or better, if the XDM is read into memory and the whole thing doesn't fit, then, well, there's only one thing you can do, and that is to use streaming. Or maybe you can split it up in smaller chunks, but not every data scenario will be applicable to that. Another scenario, less commonly thought of, is when the output blows up. Consider a situation where you have like a relatively small input, but you're trying to find out all combinations of words or whatever. This collection of words becomes too large to fit into memory. With streaming, the streaming processor, is supposed to buffer that output a little bit, but write it back to the disk in time, instead of keeping it all in memory. And then there's a scenario like, I don't know, a Twitter feed or a news feed or a data stream from a TCP/IP connection that is intrinsically streaming. You get it one element at a time, and there's no way to get previous elements. And you want it to run, I don't know, for days, months, years maybe. And in that case, it's impossible to get down to the closing tag of the document. You can't wait for it, so it's intrinsically streaming. In that case, there's only one option. You can only use streaming in such a scenario. Michael Kay briefly mentioned performance and said about that, well, for performance reasons, you should not choose streaming. In a way, I agree with that, but if the document is too big and your memory starts swapping, then you may say, well, I can wait for that, or you can use streaming, in which case probably the streaming scenario might perform better. But in practice, the only way to find out whether a given scenario performs better than with streaming than a non-streaming scenario is measurement. A lot of this talk will be about guaranteed streamability. In the specification, we have defined guaranteed streamability as something that if your style sheet, or actually if all streamable elements in your style sheet are guaranteed streamable, then regardless of what processor you run it on, provided that it's a streaming processor, it will have to process it in a streaming way. So that's why we call it guaranteed streamable. It's not allowed for a streaming processor to have a smaller subset of streaming constructs than the one that are defined in guaranteed streamability. So it is, when you're writing your style sheet and you don't want to be dependent on processor features, and maybe you plan on running it on a different processor at some time, you really want to be sure that your style sheet is guaranteed streamable. The only slight problem with making your style sheet guaranteed streamable is that the rules that ultimately decide that your style sheet or your template rules are guaranteed streamable are complex. Michael K. pointed that out earlier. I'm just repeating it here. They are complex. If you try to read them from the spec, take a couple of weeks off. So let's go to these 10 rules that take this complex set of postures and sweeps and context postures and actually gets rid of all these terms and see what they can do to you. There's one rule, the very first rule. You have to memorize that. It's important. Because if we have this large document, this streaming document, when it comes to the process, it will come element at a time, or actually it will start at the opening tag of the element, so it knows the name of the element, but it doesn't know the contents yet. And while it processes through your document, it will not be able to look back. So the single one rule you have to memorize is use one downward select per template. This is a little example. Here I show you the XSL mode construct, which is new in XSLT-3. To switch on streaming, there are a couple of ways. You can use XSL stream, you can use XSL merge. In the examples in this talk, I will only use XSL mode. Set to streamables, yes. So all the examples that will follow assume that the mode is streamable. Once the mode is streamable, every template rule in that mode must be guaranteed streamable. This example is wrong, considering that first rule about downward select. I'm going to ask again, just to see how much, I don't know, maybe some people have had too much beer or not. What is wrong here? What's wrong with this downward select rule that I just said? It's not that obvious, apparently. I don't see any hands raising. Yeah, there? There are two downward select, yes. This one, right? So we are at the element album, and we want the song, and we want the writer. And you could say, well, song comes first and then writer, because you know that from the input stream. But the processor doesn't know that. And for the processor, suppose in the worst case scenario, the writer comes first and then the song. He will have to buffer that. Or another rule with processor implementations is that they can process expressions in any order. So they could process writer first and then song, or song first and then writer. Bottom line, there are two downward selects and we don't know where they are. Once you are at writer and the song is before that, we are not allowed to go back. So this is not guaranteed streamable. Maybe that your processor supports it, but it's not guaranteed. Oh, an obvious fix is to remove the comma and just select songwriter. Here we have only one downward select. We will come back at the end of the talk with an example how to fix song, comma, writer in a proper streamable way. Another example of a correct template rules. Here we have, we are matching the album again. We apply templates to the song. We see that here's only one downward select, song. In the template matching the song, there's again one downward select for the singer, in this case. The rest around that, they're not selecting anything. They're just strings. So they're not interesting. Now let's extend this first rule a little bit into rule number 2, because it's not just one downward select per template, because, well, you have a for each and something more in it, and then you can't really do much when you have only one downward select. So the longer version of the rule is one downward select per construct. Now, it can be a bit tricky to find out what a construct is in XSLT. We have defined a construct to be an instruction, like for each, to be an expression, to be a part of an expression, like on a path expression, all the steps in the path. To really find out this, what constitutes a construct and what not. Unfortunately, you'll have to go through a lot of the analysis, but most of the times, as Michael K. also already pointed out, when you just think about it intuitively, you'll get it right. We can try it here. I'm not going to ask the question this time, but just look at this example and think of what are the constructs here. And I'm going to show the next slides, and you can see for yourself whether you were right or not. Let's give you 10 seconds. 5. Good, you all know it. This is the first construct. The for each. Actually, literally the for each is inside a sequence constructor. I'm going to ignore that for a moment. So we consider the for each the first construct. Here's the second one. The applied templates, which is nested in the for each. Again, the for each itself is a sequence constructor, but if the sequence constructor contains only one instruction, the streamability of that instruction is the same as the one of the sequence constructor. So we're only interested in the applied templates construct here. Here's yet another one. It's the expression. And maybe this one doesn't come or does come as a surprise. Song and songs are separate constructs here. And each of them are supposed to be analyzed. And of course, song text, the last expression. Now you may have noticed that I don't consider the whole Excel template a construct. That's for a reason, because declarations are treated differently. We don't go over them as construct. I actually don't know how we call them in the sense of streamability, but suffice it to say that we don't need them for analyzing a certain construct for streamability. Now, so much about downward expressions, only one per construct. Another thing that you are allowed to do, and you should use a lot, is write your expressions in such a way that you only use motionless expressions. Now, what exactly constitutes a motionless expression might not be so obvious at first hand. When a processor goes through that same tree, it remembers a stack of where it has been, but only from all its ancestors and the node it's currently on, plus all the namespaces that are in scope, plus all the attributes that are in scope. And maybe I forgot one small thing, but that's just about it. So you can access ancestor or ancestor itself. We actually call that a climbing expression, but in most cases it ends up being a motionless expression because you don't have to move forward into the tree. That information is readily available and you can use it. Let's look at a few of these expressions. I can ask the name of a parent. Name here is a property of the node, so I'm allowed to use that because we know the name of the node before continuing. I can ask more than one attribute. You might think of this as there's like 2 downward selects, but it's not because the attribute access, you can freely use more of them because they're motionless. Functions that don't operate on nodes at all, like current date time. You can use them whenever you want them. Functions that ask a property of a node, like has children. Now there has been some debate, but that has children has to peek forward to find out whether a certain element has children. But we have defined that as that a processor is allowed to just peek forward to the next starting tag, and then it can determine whether or not it's children, and that kind of buffering is allowed. So this is also a motionless one. And doc, or document, or collection, the document function in XPath returns the whole document deterministic. So your processor cannot really process that in a streaming way, because once you have that document in memory and you read it multiple times on the same URI, you will get the same document back. So we have considered doc to be a motionless construct. It reads some external document, and the nodes that are returned you can use in whatever way you like. Here are some ways where it doesn't go right. We already established that the attribute access is motionless. But you cannot pass on that attribute access because if in the next template where it is used, you get the reference to this attribute access, you would be able to move away from that. So suppose with these two templates here, you have an input something like this, author, books, some book children. Then on the first applied template, you select the name. Then the copy of select the books, and actually moves the pointer downwards to the books, to the bottom of the books. And at the same time, the matching template is called, which calls the ancestors of the original attribute. So it has to move back. That's not allowed. So you cannot pass on references of nodes. We will see that again when we talk about variables. One way of fixing it, however, this is actually not a good fix. There's an error here. I'll leave that for you to think about it, and if we have questions in the end, you may answer it. This is still not allowed. This is not correct. Let's move on to the next rule. Rule number 4. Once you're moving up the tree to the ancestor axis or the parent axis, you cannot move down again. So this poor sloth, think of him when you move up. You can move up, but never down. In this little template, we are the author element, and we're trying to select the parent paper element and create a copy of that. We are moving back from the author and then trying to select everything. And at the same time, trying to keep the focus on author. That's not allowed. You can't do this in streaming. So it's like moving up to the parent axis and moving down, selecting everything underneath it. Well, so suppose you were on the author element, you moved back to the paper element, you see that the name and the publisher were already visited, so you can't select them again. It's not guaranteed streamable. Node references. Since XSLT2, well actually in XSLT1, people have grown accustomed to using node sets and that kind of extension instructions to allow copying nodes around. In XSLT2, the sequence instruction came about and allowed you to keep a reference to the nodes. Same thing as if you have an Excel variable with select expression, you actually return a reference to these nodes. With streaming, you cannot do that. You're not allowed anymore to move around references to nodes. There's a workaround for that. We'll see that in the next rule. So something you might be very familiar to is just creating a variable and pointing it to the current node or to a certain element, or even to a motionless select expression, attribute age. You can't do that because when the node is used again somewhere elsewhere in the same scope, we don't know what's happening to it. Maybe you have an expression on it that again moves back or forward or around. And while it might be possible to create some kind of static analysis that allows this kind of constructs, it proved to be too complex to write up those rules. So at some point we just said no references to streaming nodes. This is allowed. So if you are just interested in the attribute name, the contents of it, you can make a string of it. Once you have a string of it, it's not a node anymore. You don't have a reference to a node. You can move it around. So you're allowed to use variables, just you cannot use them with references to streaming nodes. Now I said there was a workaround, and actually there is. You can hide from the processor. You can say, I'm cloaking this part, this subset, this selection, and I'm saying don't apply streamability rules with it. Actually, what you're going to do is something like the node set instruction from XSLT1, however we call it copy of. And with a copy, you create a real copy of the nodes, and you say, I know they're not too big. They fit into memory. It's all right, and I can do whatever I want with it. So this example, we select a copy of the current node, move it around to a non-streaming mode, and in a non-streaming mode, I can do preceding, sibling, access, select multiple nodes, whatever, free-ranging expressions. It gives you the freedom back, and you can do some kind of windowed streaming where you just select smaller sets of nodes and work on those. Streamable patterns. The patterns that you use in the matching template also have to be streamable. And kind of the same rules apply, that you cannot have two downwards expressions, but they work slightly different. For instance, you cannot have an extra downward select inside a predicate. You can't use a numeric predicate as the top level predicate. Likewise, you cannot do this. You can't use an access that is free-ranging, like preceding. You can't use keys. And you can't start with the variable references. These are good, though. You are allowed a motionless expression inside a predicate. You are allowed to walk the ancestor axis, because we already saw earlier, the ancestor axis is motionless. You are allowed to use doc inside a predicate, and the attribute access here is motionless again. Again, attribute access, motionless. It's totally fine. Selecting making a path expression, allowed. This may come a bit as a surprise, but once you have a text node, we know that there's no children at all, so we've allowed that as a motionless expression as well. And you can search a text node inside a pattern predicate. And here, you are allowed, again, to walk the climbing axis to the parent to find out what the name is. I just saw that I had only 5 minutes left. It's probably now 2.5 or something, so let's try to do the next two rules quickly. Templates must be grounded. The reason why we need them grounded means that it does not return any references to nodes, streaming nodes, that is. And when you make templates grounded, you allow applied templates, and we know that whenever something returns, it will not be a reference to a node. This situation here is wrong, because XSL sequence selects the nodes and creates references to it, and you cannot return them. So this is not guaranteed streamable. If you turn that into a copy, you create a copy of a node, that's fine. If you turn that into a value of, you create a string of the node, that's also fine. That's what grounded means. You don't return a reference to a streamed node. Motionless filters. They're somewhat similar as the patterns. Anything that goes into the bracket expression must be motionless. I'll just browse quickly through these. Again, the attribute access is motionless. An instant of operation is motionless because it asks for the property of a node. Ancestor is available. Again, ancestor is available. Multiple ancestors are even available. And again, the text example from earlier. Now, for the last 1.5 minutes, let's have a quick look in fork, which helps us with the very first example we saw, where we tried to use 2 downward select expressions. Remember the song, comma, writer? With fork, we are telling the processor, okay, from this point on, I want you to make multiple starting points in the streaming document that you're accessing. And as in multi-threading, just go through each of them in parallel. It looks like this. XL4 can only have XL sequence as its children. And XL sequence must return, again, a grounded expression. That's why I use XL value off here. And rewriting this expression into a fork expression becomes streamable, because you tell the processor, split it up and start streaming on the same node multiple times. You could also do, well, a kind of a sort where you, in the first, you first want all the error entries, and in the rest of the output, you only want the warnings. A full sort is, as far as I know, not possible in streaming. Considering the time, I don't have time to go over the flowchart, so it looks like this. And unless you have very good glasses, I don't think you can decipher that. If we zoom in a little bit, it looks a bit more like this. Here's your starting point, and probably tomorrow or the day after this, I will make this online. So if you like the exercise, you can go through the exercise and see how it works with the flowchart to determine whether or not something is streamable. As you can see, there's quite some steps for a relatively simple expression, which is why we consider it so complex and arduous. Conclusion, you should know when you write streamable style sheet, remember to write them guaranteed streamable so you can use it on any process you like. Remember the 10 rules, which makes life really, really much easier, as you could see from the last 20 or so slides that I browsed through. Using the real rules is a lot of work, but if you need it in a certain scenario, you can. I will publish this and updates to the chart when there are changes to the spec on this location. It's currently not yet available. I'll make it available later today. And, oh, that's about Exselt. Anyway, that was it. Thank you. Still time for questions?
Still time for 2 or 3 short questions. Over there, yeah? Jonathan?
So Abel, I first off really appreciate the nice, clear presentation back here in the nosebleed seats. Hello.
Oh, hi.
Nice, clear presentation. Now, my question is, if I take this presentation and I say, okay, now I know how to do streaming XSLT processing, Abel told me everything I need to do, what % of what I know, what I really need to know, did you show me so far? How likely am I to actually write style sheets that stream based on just this knowledge? How much more knowledge do I need to get really dangerous?
That's a good question. I think it will be hard to really quantize whether from all possible streaming scenarios, they fit in these rules. But conversely, if you only use those 10 rules, you are pretty much darn certain that you will end up with a guaranteed streamable scenario, style sheet, templates, stream instructions, and so on. But I think we have to put it to the test to really find out how much is covered and whether or not we need 1 or 2 more rules.
Okay, and the last question will be from George.
George Bina from Oxygen. Do you plan as implementing an XSLT processor, 3 processor, and mic also, to give some feedback to the users, you know, after you execute a style sheet, so that I know that my style sheet was executed in streaming mode, or do I get an error? you know, if it breaks the streaming rules?
Yes, our own processor currently does optimistic streaming in the sense that it does not give feedback on every possible currently streamability error that you may have made. And we're working hard to make a more, to give you a more sensible feedback, like this particular construct is not streamable because it breaks that and that rule. Because otherwise it will be very hard to find out whether something is streamable.
Okay, but when I run a transformation, I know at the end that it worked in streaming mode or not, right?
Yes.
Okay, so thank you very much again.